Page 35, number 10. I'm not going to go through all of these, just a few select ones. Page 35, number 10. Look at the directions. Take this rectangular XY and give me polar R theta. Give me polar R theta. All right. I have a bunch of these formulas up here. None of these help you out on this one. Graph it. Do a quick sketch right now. Go ahead. Do a quick sketch. -4, 4. Do a quick sketch for me. What quadrant you put -4, 4 in? What quadrant? Here we go. 5. What quadrant you put it in? Quadrant 2. Yep. Okay. You need, if it's going to be a polar coordinate, you need an R value and a theta value at the end. R value, that's the distance from the center to that point. So draw an arrow or draw a line to it. How do I find that distance? What did we do in class? Let's go. What did we do in class? How do I find that distance? 12. What do you want me to make out of that? Yep, right triangle. Before I head into Pythag, what can I label this bottom part of the triangle? Whoa, nope. Here we go. 3. What can I label this bottom part of the triangle? -4. And how about this side? 4. I'll give you guys a minute. Go ahead, do Pythag. And that's equal to R squared. And I'm not going to look for you to break it down at all. Don't worry about simplest radical form. Just keep it underneath the radical. 6, you're up. What'd you get for that hypotenuse length? Radical 32. Fine. Perfect. So there's your R value. Now to theta. What quadrant are we in again? To quadrant 2. So I need the angle, guys, in quadrant 2. A lot of you guys, when you did this on your own, you just found the reference angle. I don't want the reference angle. I want this angle in quadrant 2 in radians. Anybody remember how we found it? 3, what did we use to find that angle? Sine, cosine, or tangent? Tangent. So here we go, everybody. Tangent theta equals opposite over adjacent. Opposite over adjacent. Here we go. 6. What do you got for me? Opposite over adjacent. 4 over -4. And then everyone remember where you go to the calculator. Once you have that set up, second tangent. Everyone go ahead. Second tangent. I'll ask somebody what the angle is in a second. When you're ready, what's that angle measure? 45. Hey, that's the darn reference angle. That's not in quadrant 2. All right. We're going to use that 45 right here. There's 45 to find the angle in quadrant 2. Now, can I ask you guys a preference? Because I want to go with the majority here. Do you want to turn that into radians now, or do you want to wait to the end to turn it into radians? Wait to the end? Okay, you got it. So now the next question I'm going to have for somebody is, how do you use 45 to find the angle in quadrant 2? I don't know if you guys got to memorize this, whatever. All right, if I'm in quadrant 2, how do I find this angle using the reference angle? What's your 11? What's your plan here? 180 minus the reference angle. If you're in quadrant 3, what do we do? Add it. And if you're in quadrant 4, you don't use 180 at all. We use 360 minus the reference angle. All right, so your angle will be 135. You guys said, hey, I prefer to turn it into radians at the end. Okay, no problem. What do I multiply it by to turn it into radians? 16. What do I multiply that by? Pi over 180. Guys, all I'm asking you to do is keep the pi in your answer and reduce 135 over 180. That's it. Just reduce 135 over 180 in your calculator. Radical 32, comma, what was your angle finally? In radians. Got to be in radians. 11. Angle in radians. 3 pi over 4. There it is. That's my final answer. That's what I'm looking for in polar. Anything you want to ask right there before I get to the next one? That's probably the most work you're going to have to do right there when you have to go to a rectangular to an r theta value. Anything? Going. Okay, go to 14 real quick. Just a special type of one on 14. 1, 0. Throw it on a quick sketch. Let's go. Quick sketch. 1, 0. This is not going to take us as long as the last one on number 14. 1, 0. It's not in a quadrant, is it? Okay, so this should be pretty easy now. I don't have to do any of this work up here. Hope you realize that. I don't have to do any of that work. What's my R value? The distance from the center to that point. Yep, 1. And then the angle. Don't say anything. The angle here. Right there. That's it. 6. What's that angle there? What is it? 180. 0. There it is. Okay, that's it. If somebody put 2 pi, I'd be okay with that. 360, 2 pi. I wouldn't accept 360 because it's got to be in radians. All right, but I would accept 2 pi. Everyone all right with that? So when it's on the line, no big deal. 90, 180, 270. All right. Hey, how's everyone feeling? All right? We good? Yep. No negatives, always positive.
Like if it's not,
Unless, keep going.
if it's not 1, 0, if it's negative 1, 0. So then
Okay, if it's negative, so the answer is going to be 1 pi. Good. This R value is always positive. The angle is always positive. Okay. Good, Matt. Good. Everyone. Oh, yep. Everyone have a good weekend. Good to hear. All right, here we go. 17. Take your rectangular. Now I need thetas and r's. I need thetas and r's. That's where your substitutions are going to come in. I'm not giving them to you Wednesday, guys. All right, I'll leave them up there until Wednesday. However you remember them is up to you. All right, however you remember them. All right, let's start this off. I got an X in there. I got a Y in there. What do you want to substitute in first? 14. Okay, r cosine theta, I can substitute in for X. So I have 5 r cosine theta all squared. What do you want to substitute in next? It's up to you. 15, what do you want to substitute in next? 5 times r sine theta. Still got to square it. And then I'll also do that to the other side. I'll plug in 3 times r sine theta. Everyone all right with the substitutions? Everywhere I saw an X, it gets an r cosine. Everywhere I see a Y, it gets an r sine. Anything you guys want to ask there? Okay, how do I deal with these squareds? Yes, Declan, go ahead.
I don't know if it's on this problem, but the last time you said there's like one time where it's equal to 1.
That might be coming up soon.
Right.
Not yet, though, but it's coming up. Matt.
Could you have taken a 5 out in the beginning and then?
I'm glad you brought it up. You could.
Can I just?
I'm not going to take. You could take it out at the beginning. I'm going to take it out in a couple minutes here, but
Yeah.
yes, you could take it out in the beginning. What?
Can I ask a question about that?
Okay.
Like, I don't know if this is really. And then, would you put the 5 over and then make it R? But then would that?
You would just leave it out there
You would just leave it
until the end when we have to move it over.
And the final answer can't have a.
It's got to be R by itself. This final answer is going to be R equals something. Okay, good.
So that's what
Any polar equation's got to be r equals something. All right. All right. From here, how do I do r cosine squared? We've done that a couple times already. Here you go. 13. What do I do here? So 5r squared cosine squared. Nice job. And I can actually remove the parentheses there if you want to. 5r squared cosine squared. Thanks, Trent. And then over here, you want to keep going, Trent, because it's kind of the same. Yep. And then over here, just 3r sine theta. Okay, I'm going to stop there real quick. Anything you want to ask? That's how you square. You square the r and you square the sine or the cosine. Matt said take out the 5 at the beginning. Okay, or I could do it right now. I could take out a 5 and there's something else you can take out of the left side. That's in common. 12, the 5 and what else could I take out? R squared in common. So I'm going to take a 5r squared out to the left side, everyone. Let me know what's left. 8, what's left? Yep, plus. Yep. And this goes back to Declan's question earlier. This one's a beast. Somebody has to remind me. I got to write it up there before we leave today. Cosine squared plus sine squared, same as 15. Same thing as what there? 1. So this is just going to become 5r squared. This is equal to 1 right here. And remember, I think I just said it to Matt, it's got to be r by itself. It's got to be r by itself. So what do you suggest I do here to get r all by itself on one side? This might be where some people get stuck here. What can I do on both sides just to have a single r here? 3 suggestions?
You divide 3r by both sides.
Divide r?
Yeah.
Okay.
Also take a 3 out. So then it's 5 over 3r.
Okay, hold on. So you want me to divide r on this side?
Or
Okay, but then the sign's still left.
Yeah.
Let's see. You want to divide r on that side?
I divided it by 5. By 3, I meant. Sorry. Then it's 5 over 3r squared, which didn't make sense.
Because you just want r all by itself, right? And now you're adding to it, really. So go on this side now. 5. Yeah. Watch what happens. Ready? What's left on the left side now? That's what I wanted. And then over here, that's gone. What am I left with on top here? 14. What am I left with on top? There you go. That's it. Now, you could get away with doing that. You're just going to have to bring stuff back over to the right side anyway. All right? R by itself. Questions from you guys there? Going. We all right? Substituting in, and I got one other type of problem here for you. I forget which one it is. Oh, probably number. What's your deal? Just whining again? What, Matt? Okay, hold on. Let me get to your level here. Okay, go ahead. What do you want me to do?
No, well, can you write x squared plus y squared equals 3y over 5? Because that's like, you know how I said originally you just took out a 5?
Okay, so what do you want me to do? X squared
Plus y squared equals 3y over 5. Because I took out a 5 originally. And then could you put r sine theta for the y and then the left side?
Well, this is r. What's x squared plus y squared? R squared.
Yeah, so if I put r squared equals 3r sine theta over 5, and then just divide by r, yeah, and then that's the answer right there. Or multiply by 1 over r, right? No. Yeah, that's why.
Well, where did this come from?
That the original question was 5x squared
Yep.
plus 5y squared. So then I took out a 5. What is that?
So you took out a 5 here.
Yeah. 5 parentheses x squared plus y.
And then you divided both sides by it.
Correct.
Right?
Yes.
That's equal to r squared, and that's equal to r sine, which is what we have right here, right?
Yeah.
And then you tried to divide by r. But here's the problem. You divide by r, right?
Yeah.
Okay, this becomes, you remember doing back in the day, keep, change, flip, right? So this will be 3r sine theta times, now I got to flip that. Yeah. You're still back at 3, what we got as our original answer.
Isn't that just so much faster though?
My worry is people would forget what the heck to do here. Because it looks pretty bad. All right, but yeah, you can do that. Not, maybe we're not at all at your level though. I think they're all. Everyone hear what Matt's saying? Everyone. Yeah. No. What Matt's saying is nobody's at. You guys are all beneath him. That's what he's basically saying. Am I right? Anybody? That's what he's saying. Okay. Go to 20. Okay, this is what we had a little trouble with on Friday, and I understand it. Now take these r and thetas and make them into x's and y's. First thing, I got a secant here. I wrote it up here, but it's not going to be up there on Wednesday. What can I substitute in for secant? 1 over cosine. Okay, so I have 5 times 1 over cosine. I do not like the way that looks. Can somebody just clean it into one nice fraction for me? I do not like the way that looks at all. Just one fraction for me. 11, a little help cleaning it up. R equals. There we go. Okay, remember, go back to your substitutions over here. Guys, I need your help getting an r cosine theta, an r sine theta, or an r squared so I can plug in. You need to get me one of these 3 right now by doing something to both sides. Okay, so take a look at it right now. What can I do to both sides to get one of these 3 so I can substitute in? I think you can eliminate getting an r sine theta because sine's not even in there. So can you get me an r cosine theta anywhere? And can you get me or maybe an r squared somewhere? So I can substitute in. Remember, I need x's and y's in here now. No thetas, no cosines, no r's. Your suggestion on both sides. 15, any suggestion? Can I get an r cosine somehow? Can I get a r squared somehow? One of those 2? Can I do anything to both sides here to get an r cosine or an r squared? I can cross multiply or multiply both sides by cosine theta. That's basically what you're doing. Everyone see that? So go ahead, cross multiply for me. What do I end up with? 9. What do I end up with when I multiply both sides by cosine? Okay, ready? Multiply this side. Well, hold on. Not even at that point yet. Not at that point. Okay, what happens over here on the right side when I multiply by cosine theta? Well, this side right here. I multiplied both sides by, what's that? It does. What am I left with? 5. Multiply by cosine theta on the left side here. What do I end up with? R. What are you substituting in for r cosine theta now? Here you go, 6. R cosine theta. What do I substitute in? X. Guys, do I have any more R's or thetas left? Okay, you did what I asked. Made it into X's and Y's. Questions? And then 22, I don't want you to overlook things. Because this looks pretty complicated. And you're like, oh, should I do this? Multiply by this? Take a deep breath and look at the original problem, please. Take a deep breath and look at the original. Because there is nothing you have to do. You do not have to do a darn thing here. Because 2, what do I have right here? 2? 5x. Our cosine is the same thing as x. What do you got right here? Our sine, y. Don't have to do a thing. So don't think you have to go multiply by everything every time. Okay, between now and the end of class tomorrow, here's your 2 jobs. All right, end of class tomorrow, between now and end of class tomorrow, packet page 22, and then packet pages 35 through 36, 10 through 22. And yes, I am checking it for a grade on both of them. All answers are on Aspen. So have your laptop out right now. I prefer do not use your phone, please. I'd appreciate it if you don't use your phone. All right, or get with somebody who has a laptop so you can see the answer key. All right, I'll come around, help you out. I don't think anybody will finish this before the end of class. Maybe not, maybe. I don't know. But you got today and all of tomorrow to finish all of this. Yes. Okay, 1 second. All right, everyone good? Okay, that's what we're working on right now. Let's get to it. Page 22, and then pages 35 to 36. Getting ready for Wednesday.